Okay, let's start our lecture. So in few of last videos we were discussing about single random variable and their probability mass function, or in short PMFs. When I started giving the lectures on random variable, at that time I show you that for an experiment we can have multiple random variable associated with that experiment. Now we will be discussing multiple random variable. Before you start watching at the multiple random variable, make sure that you have a good understanding of what is random variable, and you should have good understanding of about the single random variables. Let's start with this multiple random variable. So let's suppose we have a probabilistic model, and on that model we have defined two random variable. So let's suppose the first random variable that we have for an experiment, or the for an probabilistic model, that is x, and the second random variable is y. And let's suppose we have also associated probability mass function of this random variable. So this probability mass function tells you about this random variable x, and this probability mass function tells you about this random variable y. If you observe here, this probability mass function, or knowing these probability mass function, doesn't give you the information about how these two random variables are related, right? So if I ask you, can you give me with this info that you know the probability mass function of this random variable x and probability mass function of this random variable y. Now I am asking a question that what will be the probability that random variable x will take the value 1, and at the same time random variable y will take the value 2. What's the probability? Can you answer this question at this moment? No, you cannot answer this question. Why? Because you don't know how these two random variables are related to each other. So knowing their individual probabilities mass function doesn't give you the information about how these two random variables are related to each other. So if you have still doubt that why we cannot answer this question having the infos about individual PMF of these random variable x and y, many students have in their mind that you can simply say that it will be equal to probability that random variable x will take the value 1 times probability that random variable y will take the value 2. So what assumption you are making in your mind? That these two random variables are independent. But I have not given you any information that how these two random variables are related to each other, right? You can think like this also. So in basic probabilities you must have seen that or you have already found that probability of happening of these two events simultaneously, or we can write that probability of A intersection B. That depends. If these two events are independent, then that probability will be probability of A times probability of B. But if these two events are not independent, then they will fall into the category of the conditional, right? So right now I haven't discussed anything about dependent or independence of random variables. We will discuss in further videos. But in order to answer this type of question, we will need the information that tells us what value of x tend to occur together with what value of y, and this information is captured what we call is a joint PMF. Let's look at the notation for the joint PMF. So in case of single random variable, so probability that random variable x will take the value little x. So we have indicated this probability with this notation, that is small p subscript x. So basically this small p is the probability mass function, and this subscript x tells you that for what random variable you are talking about. So that is what I have denoted here for the notation for the PMF of this random variable x, and for the notation for this PMF of this random variable y. Similarly, we can have the notation for joint PMF. So how? So what is this? So this is the probability when we carry out the experiment, we happen to see that random variable x takes a value little x, and simultaneously we see that random variable y takes the value little y, and this quantity we indicate with this notation, that is a small p. So small p means we are talking about the probability mass function, and since we are talking about this random variable x and y, so subscript will be x comma y, and it will take the argument, or it will be the function of x comma y. So depending upon what pair you are talking about, you will get different probabilities, right? Now let's assume that these random variable x and y taking the values from some finite set. So we might have this kind of table for this joint PMF. So if you look here, random variable is taking the value 1 2 3 4, and random variable y is taking the value little y, that is 1 2 3 4, right? And this table gives you the information when random variable takes the value 4, what's the and simultaneously random variable y takes the value 2, what's the probability of that. So we asked initially this question, and once we have this joint PMF, we can easily answer this kind of question, right? So we asked that what will be the probability of this random variable x y taking the value 1 comma 2 simultaneously, right? So we can easily look at this table, and we can say when random variable x takes the value little x, that is 1, and simultaneously y, random variable y takes the value little y, that is 2, so that is 2, and it is 0, right? In this case, we might ask the question like, what is the probability that random variable x and y take the value 1 and 3. We can easily look at the table, right? So random variable x is taking the value 1, and at the same time random variable y is taking the value 3, and the probability of that is 2 divided by 20. So in next video we will be looking at the properties of this joint